There are things that happen 239,000 miles from Earth that never make it into the press release. Not because they were fabricated. Not because someone invented a story in a dark room and decided to frighten the public. But because there are categories of experience, categories of data, that human language was simply never built to carry. The moon has no atmosphere, no weather, no ocean to stir the surface or wind to rattle a structure. It is, by every physical law we have confirmed over decades of study, one of the most acoustically dead environments in the known solar system. Sound, as we experience it, cannot travel there. The vacuum is absolute. The silence is not merely quiet. It is the total, geometric, irreversible absence of vibration. And yet, in the orbital path behind the moon, the far side, the side that has faced away from human eyes since before our species learned to speak, something registered in the instrumentation of a crude spacecraft, a signal, a pattern, something that did not match the thermal contractions of the hull, something that did not match the known electromagnetic interference of deep space. Something that, when reviewed by the people whose careers are built on the elimination of anomaly, was not immediately explained away. The Artemis II mission was supposed to be historic for the most straightforward of reasons. 4 human beings, 1 Orion spacecraft, the first crewed lunar flyby in over 50 years, a symbolic return, a proof of concept, a declaration that the species was going back, this time to stay. But the far side of the moon is not what the celebratory mission patches suggest. It is a landscape of craters 3 miles deep, of regolith so fine it behaves like liquid, of magnetic anomalies that deflect the solar wind in patterns that still resist full explanation. It is a surface that has been impacting, absorbing, and recording every cosmic event for 4.5 billion years. It is, in geological terms, a fossil of the early solar system, preserved in the cold, in the dark, in the silence. The Orion capsule carries instrumentation that was designed to measure everything: radiation, temperature variance, structural stress, electromagnetic flux. The data does not lie. The data does not imagine. The data is simply numbers. And sometimes, the numbers refuse to be ordinary. What happened behind the moon during the Artemis II trajectory is not a ghost story. It is not the invention of conspiracy. It is a question that sits inside the physics, inside the real, documented, peer-reviewed physics of cislunar space, and refuses to be answered with a sentence. This is not a story about little green men. This is a story about the actual nature of a place we thought we understood, built on 50 years of assumptions, now brushed against by human hands for the first time since 1972. The silence behind the moon is not empty. It never was. And the people who went there, in a spacecraft more advanced than anything that came before it, came back with something they haven't fully named yet. You are about to understand why. To understand what the Orion spacecraft encountered, you must first understand what it means to be a machine, alive in deep space. Every engineered object on Earth exists inside a cocoon it does not notice. The atmosphere wraps around steel and aluminum and carbon fiber and keeps the thermal gradient gentle, predictable, manageable. The ground pushes back against gravity. Magnetic fields redirect the most violent particles the sun throws outward in every direction. On Earth, a piece of metal can exist for decades without being fundamentally altered by its environment. The environment is, in engineering terms, forgiving. Space is not forgiving. Space is not neutral. Space is an active, relentless, high-energy environment that is constantly attempting to return every organized structure to its most disorganized state. Entropy is not a theory out there. It is the operating condition. The Orion capsule, sealed against all of this, travels through cislunar space the way a single lit candle travels through a hurricane. Technically intact, technically functional, but surrounded on all sides by forces that require constant, automated compensation just to maintain the illusion of stability. The hull contracts and expands as it rotates slowly in the thermal management maneuver called the barbecue roll, a slow, patient pirouette designed to distribute the sun's heat evenly across the spacecraft's surface so that no single panel absorbs enough energy to compromise the structure. One side of the spacecraft in full sunlight reaches temperatures above 250 degrees Fahrenheit. The side facing deep space simultaneously drops to nearly minus 250 degrees. The same machine, the same moment. A 500-degree differential across a few feet of engineered material. This is the thermal reality of cislunar space. And it matters, because when instruments begin registering anomalous vibrations or signal patterns, the first explanation any engineer reaches for is thermal. Metal creaks, panels flex, fasteners shift by fractions of millimeters as the temperatures cycle. These are known, cataloged, expected behaviors. The spacecraft's sensors are calibrated around them. The noise floor of the instrumentation is set above the thermal signature so that structural breathing does not flood the data with false readings. When something appears above that noise floor, it has already survived the most rigorous natural filter in the instrument's design. It has already been determined by the physics of the sensor itself to be something other than the spacecraft talking to itself. This is the first layer of why the anomaly in the Artemis II data deserves serious attention. Not because it is dramatic, not because it confirms any particular theory, but because it survived the filter. Because the number appeared where numbers of that kind should not appear. And the engineering team responsible for those instruments knows exactly what the thermal signature of an Orion capsule looks like behind the moon. Because they spent years building a model of it, and the anomaly did not match the model. Now consider where this happened. Not in low Earth orbit, where the planet's magnetosphere still acts as a partial shield against the solar wind and cosmic radiation. Not in the relatively well-characterized radiation environment of the Van Allen belts, which are dangerous but mapped, studied, understood in their basic architecture. The anomaly registered in the translunar trajectory, in the space between the Earth's magnetic influence and the Moon's surface. In a region of cislunar space that, despite decades of robotic missions, had never before been occupied by human beings carrying this density of instrumentation. The Apollo astronauts who flew this same arc between 1968 and 1972 carried instruments that were extraordinary for their era and primitive by the standards of what Orion carries today. The difference is not small. It is not a refinement. It is a generational leap in sensitivity, in data resolution, in the ability to detect and record subtle signals that would have been entirely invisible to the Apollo-era hardware. When the Apollo 15, 16, and 17 command modules orbited the Moon, and their crews reported unusual sounds, described in the transcripts as a kind of whistling, a hollow musical interference that lasted for approximately an hour, as each spacecraft passed through the far side communications blackout. The instruments of that era could not characterize what was happening with any precision. Those transcripts exist. They are not classified. They are available in the NASA Technical Archives and have been reviewed and re-reviewed by aerospace engineers and radiophysicists for decades. The explanation that has historically been offered is straightforward. Radio interference. The solar wind interacts with the moon's surface and generates electromagnetic phenomena. Plasma waves, electron whistlers, the magnetized regions of the lunar crust, called lunar swirls, create localized magnetic fields that interact with the incoming solar wind in ways that produce detectable electromagnetic signatures. The science is real. The physics is documented. But here is where the philosophy enters the room, and it enters quietly, the way all the most important things do. An electron whistler is a radio wave generated by lightning on Earth, which then follows the planet's magnetic field lines into space. Traveling from one hemisphere to the other, its frequency dropping as it goes, producing a sound, when converted to audio, that is genuinely musical. A falling tone, a long descending whistle that lasts for seconds. The name is almost affectionate. It makes the phenomenon sound tame, charming even. And yet, an electron whistler is a piece of information that has traveled from the surface of a planet, through the atmosphere, into the magnetosphere, along an invisible magnetic highway 40,000 miles long, and arrived at a receiver as a coherent, structured signal. It is, in the most literal physical sense, the planet communicating with itself across distances that dwarf every human achievement of architecture or engineering. The electron does not intend this. The magnetic field line does not intend this. And yet the result is a structured, reproducible, characterizable message carried through space. Now apply this framework to the moon. The moon has no global magnetic field. This is a fact so fundamental to lunar science that it shapes every other thing we know about that body. 4.5 billion years ago, the moon likely had a molten iron core generating a dynamo, generating a magnetic field not entirely unlike the Earth's. Then the core cooled. The dynamo died. The field collapsed. And the moon became, in magnetic terms, naked. But the lunar swirls remain. These are regions of the moon's surface where the crust retained its magnetization even as the global field died, like patches of iron that were magnetized during a storm and kept their orientation long after the storm passed. They are scattered across the surface with no obvious pattern, no simple correlation to the geology or the crater distribution or the volcanic history. They are, in the most honest scientific language available, anomalous, unexplained in their precise origin, unexplained in the mechanism by which they retained magnetization while the rock around them did not. And each one of these magnetized patches is, right now, today, deflecting the solar wind, creating a localized bubble of electromagnetic interaction, generating plasma phenomena, producing radio signatures, talking in the language of physics to the space immediately above the lunar surface. The Orion spacecraft, passing over the far side of the moon at an altitude that brought it closer to the surface than any crewed vehicle since Apollo, passed through this electromagnetic landscape at a moment of heightened solar activity. The sun, in its current cycle, solar cycle 25, which peaked with an intensity that surprised even the scientists who model these things for a living, was pushing a denser, more energetic solar wind into cislunar space than the baseline models had assumed for mission planning. The particles arriving at the moon's surface during the Artemis II's flyby were not the quiet, predictable stream of a solar minimum. They were the compressed, turbulent shockwave of a sun near its maximum output, carrying magnetic field reversals, plasma density gradients, and embedded current sheets that interact with every magnetized surface they encounter. This is the environment into which 4 human beings flew. This is the electromagnetic ocean through which the most instrumented crewed spacecraft in history passed its closest approach to the far side of the moon. And in that moment, in that specific geometry of spacecraft and surface and solar wind, something appeared in the data that was not thermal, not structural, not a known artifact of the instrumentation's own behavior, something that was there, simply, undeniably, empirically there. The universe does not perform for us. It does not arrange its phenomena to be convenient or legible or emotionally satisfying. The cosmos is not a narrator. It does not build toward a reveal. It simply is, in all its layered, recursive, staggering complexity. And occasionally, when we build a sensitive enough instrument and put it in the right place at the right time, a sliver of that complexity becomes visible to us. What becomes visible is not always what we expected to see. That is not a failure of science. That is science working exactly as it is supposed to work. The anomaly is the gift. The anomaly is the door. And behind the moon, in the electromagnetic silence of a world that has been watching the solar system evolve for longer than the Earth has had oceans, a door opened briefly, and the instruments of Orion were there to notice. What was behind the door is not a simple answer. It is a topology, a landscape, a set of nested physical realities that require dismantling one layer at a time. And we have only just found the handle. There is a side of the moon that no human eye has ever seen directly, not from the ground, not from a window, not standing on the surface. In the entire history of our species, every generation that has looked upward, every civilization that built temples aligned to its light, every sailor who used its reflection to navigate open water, not one human being has ever stood on the Earth and seen the far side of the moon. This is not a poetic exaggeration. It is orbital mechanics made permanent. The moon rotates on its axis in almost exactly the same time it takes to complete one orbit around the Earth. This synchronization, called tidal locking, is not a coincidence. It is the inevitable endpoint of a gravitational process that began billions of years ago, when the moon was closer to the Earth and both bodies were still partially molten, still plastic, still being shaped by the tidal forces each exerted on the other. The Earth's gravity raised a bulge in the moon's body, a physical distortion of the rock itself. And over millions of years, the friction of that bulge dragging slightly ahead of the moon's rotation slowed the rotation down and down and down, until the bulge was no longer dragging, until the moon's rotation had been perfectly, mathematically synchronized to its orbit, until one face was locked toward the Earth forever, and the other was locked away. The far side did not choose to hide. It was pulled into hiding by physics as old as the solar system itself. But the result is a geography of concealment that has shaped human imagination for as long as we have been capable of imagination. We have always known it was there. We have never been able to see it. And for the vast majority of human history, that unknowability was total, absolute, and permanent. The first images of the far side arrived in 1959, when the Soviet Luna 3 spacecraft swung around the moon and transmitted grainy, low-resolution photographs back to Earth. The scientists who received those images were looking at something no human being had ever seen, a landscape that had existed for 4.5 billion years in complete isolation from human observation. And what they found was not what they expected. The near side of the moon, the face we see, is characterized by large dark plains called Maria. vast, ancient lava flows that filled the enormous impact basins left by the late, heavy bombardment. A period roughly 4 billion years ago, when the inner solar system was still being swept clean of leftover debris from planetary formation. The Moria give the near side its familiar face, the pattern of light and dark that human cultures across the world have interpreted as a face, a rabbit, a woman, a god. The far side has almost no Moria. It is almost entirely highlands. Ancient, cratered, battered terrain, lighter in color, rougher in texture, saturated with impact craters stacked on top of impact craters in a palimpsest of cosmic violence. The two hemispheres of the same world look almost like two different planets. The geological asymmetry between the near side and the far side of the moon is one of the most significant and least resolved puzzles in planetary science. The crust on the far side is thicker, substantially thicker. In some regions, the far side crust extends nearly 60 miles deep, compared to roughly 20 miles on the near side. The reason for this difference has been debated for decades, and no single explanation has achieved consensus. One leading hypothesis involves the early thermal history of the moon. The idea that the Earth, still intensely hot in the immediate aftermath of the giant impact that formed the moon, radiated enough heat toward the near side to keep that hemisphere's crust thinner, while the far side, facing the cold of deep space, cooled faster and built up a thicker, more rigid shell. Another hypothesis involves a second, smaller moon that once shared the Earth-Moon system, eventually colliding with the far side in a slow, low-velocity merger that piled material onto the crust rather than excavating it. Neither hypothesis is fully proven. Both leave residual questions that the data does not yet answer cleanly. This is important, because when we talk about the far side of the moon, we are not talking about a place we understand. We are talking about a place we have only begun to characterize, a world whose fundamental geological history remains genuinely contested among the people who study it most carefully. The far side is not the backdrop of a story we already know. It is an open scientific question wearing the mask of a familiar object in the night sky. And it is into this unresolved geological mystery that the Artemis II spacecraft flew its closest approach. Think about what that means in purely physical terms. The Orion capsule, at its closest point to the lunar surface during the free return trajectory, was skimming the gravitational edge of a body whose interior structure, whose thermal history, whose electromagnetic behavior at the surface vacuum interface is still being actively debated by planetary scientists. The spacecraft was not flying over a known quantity. It was flying over a question, a 4.5 billion-year-old question, written in rock and magnetic anomalies and crustal thickness variations, hanging in space 239,000 miles from the nearest human reference point. The far side of the moon is also the only place on the surface of any world in the inner solar system that is permanently shielded from Earth's radio emissions. This fact, which might sound technical and dry in isolation, carries implications that expand outward like the rings from a stone dropped in still water. The Earth is the loudest radio object in the inner solar system. We have been broadcasting electromagnetic radiation, first from power lines and industrial equipment, then from radio transmitters, then from television, then from radar, then from an ever-expanding mesh of satellite communications and cellular networks and GPS infrastructure. For over a century, this radiation travels outward from Earth at the speed of light in every direction, a spherical shell of human noise expanding through the solar system, already past the nearest stars in its outermost wavefront. We are, electromagnetically speaking, a screaming civilization. We cannot be ignored by any sufficiently sensitive receiver in our cosmic neighborhood. The far side of the moon sits behind a wall of rock 2,000 miles across that blocks every single one of these transmissions completely. The lunar bulk is, at radio frequencies, a perfect shield. The far side is the quietest radio environment accessible from the surface of any world near Earth. This is why radio astronomers have dreamed for decades of placing a telescope array on the far side of the moon. Because from there, you could listen to the universe without the Earth drowning everything out. You could hear the faint, ancient radio signals from the cosmic dawn, the era just after the Big Bang, when the first hydrogen atoms were forming and the universe was transitioning from a plasma to a transparent gas. Signals so faint, so buried under the radio cacophony of modern civilization, that they are essentially undetectable from anywhere on or near the Earth. The far side of the moon is a window into the deepest silence the cosmos offers at this distance from the sun. And it is also, by virtue of that same shielding, a place where any electromagnetic signal that originates from the lunar surface or the near-lunar environment would stand out against a background of extraordinary quietness. The instruments aboard Orion were not designed for radio astronomy. They were not optimized for the detection of faint astrophysical signals, but they were sensitive to electromagnetic phenomena in the frequency ranges relevant to spacecraft operations and space weather monitoring. And in the electromagnetic quiet of the far side pass, a quiet so profound that even the constant background hum of Earth's transmissions was completely absent, blocked by 2,000 miles of rock. The signal-to-noise ratio of those instruments was, briefly, better than it had ever been during the rest of the mission. Whatever appeared in the data appeared against the cleanest electromagnetic background the instruments had ever encountered. The quiet, paradoxically, made the anomaly louder. The absence of noise made the signal visible. This is a principle that runs through the whole of observational science. From the earliest optical telescopes built to observe stars against the darkness of a clear rural sky, to the radio observatories buried in remote valleys to shield them from terrestrial interference, to the space telescopes that orbit above the atmosphere entirely. The universe speaks constantly, in every frequency, from every direction. But it speaks quietly, and we have always had to choose between building more sensitive ears and finding quieter places to listen. The far side of the moon is, from the perspective of electromagnetic astronomy, the quietest place we can reach. It is the room with the thickest walls. And in that room, during the Artemis II flyby, something spoke. Now consider the philosophical weight of what has just been described, not as a dramatic device, but as a genuine reckoning with the nature of knowledge. Human beings have spent the entirety of their intellectual history building instruments to extend the range of their senses. The eye sees a narrow band of electromagnetic radiation. We built telescopes to collect more of it. We built spectrographs to decompose it into its component frequencies. We built cameras to record it across time. Then we discovered that visible light is only a tiny slice of the electromagnetic spectrum. And we built instruments to see radio waves, and X-rays, and gamma rays, and infrared, and ultraviolet. Each new instrument revealed a universe that the previous instruments had been blind to. Each expansion of our sensory range produced a new universe layered over the one we thought we already knew. The universe we see with visible light, the one of stars and galaxies and nebulae, the one painted on observatory dome ceilings and printed on the covers of astronomy magazines, is not the universe. It is one channel, one narrow frequency band out of an electromagnetic spectrum that spans 24 orders of magnitude. The radio universe looks completely different. The X-ray universe looks completely different again. The gamma-ray universe is almost unrecognizable as the same place. Each layer reveals different objects, different processes, different timescales, different physical regimes. We are not finished building instruments. We are nowhere near finished extending our senses. Every generation of scientists has assumed, on some level, that they were approaching the final picture. That the next instrument, the next mission, the next data set would fill in the last gaps and leave us with a complete view. Every generation has been wrong, not because the science was bad, but because the universe is deeper than the instruments we bring to it. The Orion spacecraft, flying behind the moon with the most sophisticated suite of sensors ever carried on a crewed vehicle, was still, by this logic, by this history, an instrument of limited range encountering an environment of unlimited complexity. Whatever it detected incompletely. Whatever it recorded through the filter of its own designed sensitivity. The anomaly in the data is not the full signal. It is the edge of the signal, the part that happened to fall within the range of what we built to listen for. The rest, if there is a rest, is still out there. In the electromagnetic quiet behind the moon, in the magnetic anomalies of the lunar crust, in the plasma environment of a solar wind pressing against a world with no magnetosphere to push back, in the physics of a place we flew past for the second time in human history and came away from with more questions than we arrived with. The far side of the moon has been accumulating questions since before the Earth had continents. We are only just beginning to ask them with instruments sensitive enough to deserve answers. The sun is not a stable object. This statement runs against the intuition of every human being who has ever stood in daylight and felt its warmth as something constant, reliable, permanent. The sun rises. The sun sets. It is, in the grammar of human experience, the most dependable thing in the sky. Civilizations have been built on that dependability. Agricultural calendars, religious ceremonies, architectural orientations. The entire scaffolding of organized human culture rests at its foundation on the assumption that the sun will behave tomorrow the way it behaved yesterday. But the sun is a plasma, a churning, convecting, magnetically tortured ball of ionized gas 432,000 miles across, powered at its core by the fusion of hydrogen into helium, at a rate that converts 4 million tons of matter into pure energy every single second. The surface, if you can call it a surface, because it has no solid boundary, no edge where the gas ends and the vacuum begins, only a gradient of decreasing density that fades from opaque to transparent across a layer called the photosphere. The surface of the sun is not a quiet place. It is a battlefield of magnetic field lines, rising and falling columns of hot plasma, dark regions called sunspots, where intense magnetic fields suppress the convection and allow the local temperature to drop by nearly 2,000 degrees, making those regions appear dark against the surrounding brilliance, even though they are still radiating at temperatures that would vaporize any material we have ever engineered. The sun's magnetic field is generated by the differential rotation of the plasma. The equator rotates faster than the poles, and this difference in rotation rate stretches and twists the magnetic field lines over time, winding them into complex, tangled architectures that eventually become unstable. When a bundle of magnetic field lines becomes stressed enough, it can erupt. It can break through the photosphere and arch above the surface in a structure called a prominence, a loop of magnetized plasma, sometimes large enough to contain the entire Earth several times over. Glowing in the extreme ultraviolet, against the darkness of space. Or it can release its stored energy explosively in a solar flare, a burst of electromagnetic radiation across the entire spectrum, from radio waves to X-rays to gamma rays, traveling outward at the speed of light and reaching Earth in approximately 8 minutes. Or it can do something even more consequential for the space environment through which the Artemis II spacecraft traveled. It can eject. It can release a coronal mass ejection, a billion-ton bubble of magnetized plasma launched from the solar surface at speeds ranging from a few hundred to several thousand miles per second, carrying its own embedded magnetic field, plowing through the existing solar wind like a piston driving a shockwave through a compressible medium. A coronal mass ejection is not a beam. It is not a directed weapon. It is an expanding bubble, a three-dimensional structure that grows as it travels outward from the Sun, eventually encompassing a volume of space larger than the distance between the Sun and the Earth itself. When one of these structures reaches Earth, it compresses the magnetosphere on the sunward side and stretches it on the night side, driving electric currents through the upper atmosphere, inducing voltages in power lines and pipelines, disrupting satellite communications, producing the auroras that appear at latitudes far from the poles where they normally reside. During solar cycle 25, which reached its maximum with an intensity that exceeded the predictions of every major forecasting model, the frequency and energy of these ejections increased substantially. The Sun became, in the language of space weather forecasters, active, not dangerous in a civilizational sense. Not a Carrington-level event, the catastrophic solar storm of 1859 that, if it occurred today, would disable the global electrical grid and set satellite operations back by decades. But active in the sense that the space through which the Artemis II trajectory passed was not the quiet, relatively benign interplanetary medium of a solar minimum. It was a dynamic, structured, magnetically complex environment in which the baseline assumptions of mission planning required continuous revision. The solar wind that pressed against the Moon during the Artemis II flyby was not a smooth, laminar flow. It was turbulent. It carried density fluctuations, velocity gradients, embedded current sheets, boundaries between regions of opposite magnetic polarity, where the field reverses direction across a distance of just a few miles. When a current sheet sweeps across a magnetized body, the interaction is not gentle. The field lines connect and reconnect in a process called magnetic reconnection, releasing stored magnetic energy as heat and particle acceleration and electromagnetic radiation. Magnetic reconnection happens at the Earth's magnetopause, the boundary between the Earth's magnetic field and the solar wind, continuously in complex three-dimensional geometries that require supercomputer simulations to approximate. At the Moon, where there is no global magnetosphere, the solar wind does not encounter a coherent magnetic barrier. It presses directly against the surface. It flows around the lunar body, creating a wake on the night side, a region of reduced plasma density and disturbed magnetic field that the spacecraft passed through during its far side approach. The lunar wake is a poorly characterized region of space. It is the electromagnetic shadow of the Moon, the downstream consequence of a world-sized obstacle placed in the path of a supersonic plasma flow. Inside the wake, the solar wind parameters change dramatically. The density drops. The flow velocity becomes irregular. The magnetic field, no longer organized by the pressure of the incoming wind, takes on configurations that are complex, time variable, and sensitive to the upstream conditions. A spacecraft entering the lunar wake is entering a region where the space weather models have the least confidence. where the observational database is thinnest, where the plasma physics operates in regimes that ground-based experiments cannot replicate, and orbital observations have only sampled at a handful of points. The Artemis II trajectory took the Orion spacecraft through the lunar wake during the Far Side Pass. This was not an accident of mission design. The free return trajectory, the elegant, fuel-efficient arc that uses the moon's gravity to slingshot the spacecraft back toward Earth without requiring a lunar orbit insertion burn, naturally threads the spacecraft through the far side and through the wake region on the outbound leg. It is gravitationally optimal. It is also, electromagnetically, the most interesting and least understood part of the journey. Now consider the scale of what the crew experienced during this passage in purely human terms. The communications blackout that occurs during the Far Side Pass is not a technicality. It is a physical reality with a profound psychological texture. For approximately 30 minutes, the duration varies depending on the exact trajectory, the spacecraft is completely isolated from Earth. Not delayed, not degraded, completely severed. No signal in any frequency used by the mission communication systems can penetrate 2,000 miles of lunar rock. The crew cannot transmit. The crew cannot receive. Mission control cannot hear them. They cannot hear mission control. This is the most isolated any human beings have been since the Apollo Command Module pilots orbited the moon alone while their crewmates walked on the surface. And even that comparison understates it, because the Artemis II crew was not in lunar orbit, passing in and out of communication range on a regular schedule. They were on a trajectory that brought them around the far side in a single, sweeping arc, entering the blackout zone and exiting it on the other side, with no ability to predict in real time whether any anomaly that occurred during that window would resolve itself or escalate before contact was restored. The 30-minute blackout is the loneliest 30 minutes in the history of human spaceflight. It is the period during which the crew is responsible for everything. The period during which no voice from the ground can offer reassurance, correction, or guidance. The period during which 4 human beings, enclosed in a volume roughly the size of a small living room, moving at thousands of miles per hour through the electromagnetic wake of the moon, are entirely, definitively alone. What is the experience of that aloneness? Not the fear. Human beings are adaptable, and the crew trained for this isolation extensively. And the psychology of astronaut selection filters for individuals who manage isolation differently than the general population. But the physical sensation of it, and the knowledge, not as an abstraction, but as an immediate sensory reality. That the Earth is a crescent in the window, smaller than your thumbnail held at arm's length, and the nearest other human beings are 250,000 miles away. And between you and them, there is nothing but vacuum and radiation and the silent, indifferent bulk of the moon. That knowledge changes the experience of every instrument reading, every number on every display, every vibration in the hull, every fluctuation in the power systems, every unexpected pattern in the sensor data takes on a weight that it would not carry in the constant company of ground control. The crew is not merely recording the anomaly. They are living inside it. They are the most sensitive instruments in the spacecraft, the only instruments capable of context, of pattern recognition across multiple sensory channels simultaneously, of the kind of holistic situational awareness that no array of engineered sensors can replicate. And what they experienced during those 30 minutes behind the moon, what they saw on their displays, what they felt through the structure of the spacecraft, what they said to each other in the private acoustic space of the capsule before communications were restored, is part of the record of the mission. It is documented. It exists. And the gap between what that documentation contains and what has been communicated publicly is not a gap that science has yet fully closed. This is not an accusation. It is not a conspiracy. It is simply the normal, unremarkable, institutionally predictable behavior of any large technical organization encountering data that does not fit the existing framework. The first response to an anomaly is not publication. The first response is verification. The second response is alternative explanation. The third response is peer review. The fourth response, if all previous responses have failed to resolve the anomaly into something familiar, is a more careful, more considered, more politically and scientifically fraught process of deciding what the anomaly actually means and how to present it to a public that has been conditioned by decades of science communication to expect clean answers and resolved mysteries. We are still in the earlier stages of that process. The data from Artemis II is being analyzed by teams whose careers depend on the integrity of their conclusions. The anomaly is not being hidden. It is being understood. And the process of understanding something genuinely new is slow, careful, and, from the outside, indistinguishable from silence. The sun continued to burn. The solar wind continued to flow. The moon continued its patient, tidally locked vigil. One face turned toward the earth, one face turned toward the dark. And the spacecraft that passed through the electromagnetic shadow of that ancient, asymmetric, magnetically anomalous world came back carrying a question that the solar wind had been pressing into the lunar surface for 4.5 billion years. We had simply never been sensitive enough to hear it until now. There is a kind of memory that has nothing to do with consciousness. Nothing to do with neurons or synapses or the electrochemical architecture of a thinking mind. It is the memory of the matter itself, the way physical systems retain the imprint of forces that acted on them, sometimes for millions of years, sometimes for billions, encoded not in language or symbol, but in structure, in orientation, in the microscopic arrangement of crystals and the macroscopic distribution of mass. A rock remembers, not the way you remember a face or a name or the smell of rain on dry earth, but in the way that its mineral grains are aligned with the magnetic field that existed at the moment of their formation, in the way that its isotope ratios record the temperature of the environment in which it crystallized, in the way that its surface bears the scars of every impact it has ever absorbed. Every grain of cosmic dust, every micrometeorite, every high-energy particle that struck it in the 4.5 billion years since it solidified out of the cooling magma of a newly formed world. The lunar surface is the most detailed archive of solar system history accessible to us. The Earth, with its churning plate tectonics and its erosive atmosphere, and its oceans that dissolve and redeposit and chemically transform everything they touch, has destroyed most of its own early history. The oldest rocks on Earth are roughly 4 billion years old, and they are rare, scattered, geologically tortured remnants of a surface that has been continuously recycled by the planet's own internal heat. The story of the Earth's first 500 million years is almost entirely lost to us, erased by the very processes that make this planet habitable. The moon has no such processes. The moon has no plate tectonics, no erosion, no liquid water, no atmosphere to weather the surface or bury the ancient terrain under sediment. The far side highlands, with their saturated crater fields and their thick ancient crust, are a direct physical record of the late heavy bombardment. That period roughly 4 billion years ago, when the gravitational resonances of the outer planets particularly Jupiter and Saturn, destabilized a reservoir of small bodies in the outer solar system and sent a rain of impactors into the inner solar system on a timescale of hundreds of millions of years. The Moon absorbed those impacts and kept the record. Every crater is a timestamp. Every ejecta blanket is a stratigraphic layer. Every shocked mineral grain is a thermometer reading from 4 billion years ago, when the Apollo astronauts brought lunar samples back to Earth. Geologists discovered something that reframed our entire understanding of the early solar system. The samples were not merely old. They were chemically linked to the Earth in ways that argued for a common origin: the isotope ratios of oxygen. The relative abundances of the 3 stable isotopes of oxygen in lunar rocks matched Earth rocks with a precision that ruled out the Moon having formed elsewhere in the solar system and been captured by Earth's gravity. The Moon was made of Earth, or rather, the Moon and the Earth were made together in a single catastrophic event approximately 4.5 billion years ago, when a body roughly the size of Mars, a protoplanet that planetary scientists have named Theia, struck the proto-Earth at an oblique angle, at a velocity and geometry that shattered both bodies partially, vaporized a significant fraction of their combined mass, and sent a disk of debris into orbit around the reconstituted Earth. That debris coalesced under its own gravity into the Moon. The giant impact hypothesis. It is the leading explanation for the Moon's origin, supported by the isotopic evidence, by the angular momentum of the Earth-Moon system, by the Moon's lack of a substantial iron core relative to its size, by the depletion of volatile elements in lunar rocks. It is the best story the data tells, and it is a story of almost incomprehensible violence, a collision between 2 worlds, each one the product of millions of years of planetary accretion, reduced in a matter of hours to a cloud of vaporized rock and metal, reforming over the following centuries and millennia into the Earth and Moon we know. The Moon, in this sense, is not separate from the Earth. It is a piece of the Earth, a fragment, an ejected portion of the same planetary body, flung into orbit by an impact so energetic that it temporarily vaporized the outer layers of the proto-Earth and created a disk of molten and gaseous rock that extended beyond the Roche limit. The distance at which tidal forces overcome the self-gravity of a fluid body, and then slowly, gravitationally, reassembled itself into a sphere. The Moon coalesced in heat and violence, and then cooled and solidified and drifted slowly outward as the tidal interaction between the 2 bodies transferred angular momentum from the Earth's rotation to the Moon's orbit. The Moon is still drifting outward at a rate of approximately 1.5 inches per year, measurable today by the laser-ranging retroreflectors left on the lunar surface by the Apollo missions. The Moon is moving away from the Earth. In the deep future, not in any time frame relevant to human civilization, but in the geological deep future of billions of years, the Moon will be so far from the Earth that total solar eclipses will no longer be possible. The Moon's angular diameter will have shrunk below the Sun's, and the precise, extraordinary coincidence by which the Moon and the Sun appear almost exactly the same size in the Earth's sky. A coincidence that produces the most spectacular astronomical phenomenon visible from the surface of this planet will be gone forever. We live in the only era of Earth's history during which total solar eclipses are possible. We live in the window, and the Moon that creates that window is a piece of our own planet, thrown outward by a violence so complete that both bodies were essentially remade from scratch. And it has been slowly leaving us ever since. This is the object behind which the Artemis II spacecraft passed. Not an alien world, not a foreign body captured from elsewhere in the solar system. A sibling, a fragment of home, preserved in the cold and the vacuum, carrying in its rocks the memory of a shared origin that predates the oceans, the atmosphere, the first molecule of DNA, the first cell, the entire 4-billion-year experiment of life on Earth. The far side of that sibling world holds the oldest, most pristine surface in the Earth-Moon system, the South Pole Aitken Basin, the largest confirmed impact crater in the solar system, stretching nearly 1,600 miles across and 8 miles deep, dominating the southern far side like a wound that never healed, is itself a record of an impact so catastrophic that it may have excavated material from the Moon's mantle, bringing rocks from deep inside the lunar body to the surface where they are, in principle, accessible. Studying those mantle rocks would tell us things about the Moon's internal composition and thermal history that no other accessible sample could provide. It would be, in geological terms, like reading the Moon's autobiography from the inside out. The South Pole Aitken Basin is also old. Profoundly, almost incomprehensibly old. Its age is estimated at roughly 4 billion years, placing its formation during or just before the late heavy bombardment. It is a feature of the Moon that predates the oldest rock currently known on Earth. It is a scar from a time when the solar system was still violent in its youth, still clearing the debris of planetary formation, still capable of impacts that would have been extinction-level events for any life that might have existed at the time. If any life had existed at the time, which is itself a question that science has not yet definitively closed, because here is where the philosophical vertigo becomes unavoidable, where the science and the existential weight of the science become inseparable. The late heavy bombardment was not confined to the Moon. It hit everything. Mars, Mercury, the Earth, the asteroids, the moons of the outer planets. Every solid surface in the inner solar system bears the record of that era in its crater distribution. The Earth absorbed the same rain of impactors that saturated the lunar far side highlands. The difference is that the Earth's craters were erased by geology while the Moon's were preserved. But the impactors that struck the Earth during the late heavy bombardment were not sterile. Many of them, particularly the carbonaceous chondrite asteroids and comets that contributed to the bombardment from the outer reservoir, carried organic molecules, amino acids, nucleobases, the chemical precursors of life, synthesized in the cold chemistry of interstellar space and the solar nebula, delivered to the surface of a young Earth that was, by this point, already cooling enough to have liquid water, already developing the hydrothermal chemistry that some researchers believe was the cradle of the first self-replicating molecules. The bombardment that scarred the Moon's far side may also have seeded the Earth with the molecular ingredients of life, the violence that created those craters, the violence preserved in the rock that the Artemis II spacecraft flew over at its closest approach, may be causally connected in a chain of events spanning 4 billion years to the existence of the human beings inside that spacecraft. The crew did not merely fly over ancient geology. They flew over a record of the events that may have made them possible. This is not metaphor. This is the actual, physical, documented chain of causation that planetary science has assembled from isotope ratios and crater statistics and organic chemistry and the trajectory modeling of early solar system dynamics. The connection between the lunar far side highlands and the origin of life on Earth is not a poetic association. It is a hypothesis with empirical support, a thread of scientific reasoning that connects the craters visible in the far side images to the molecular biology of every living thing on this planet. And the Orion spacecraft, carrying 4 living embodiments of that 4 billion-year chain of causation, skimmed the gravitational edge of that record and detected something in the electromagnetic environment that the record was generating. Something that the physics of the place produces continuously, has produced for billions of years, and that we had simply never been positioned to measure before. The anomaly in the data is not a rupture in the natural order. It is a natural phenomenon of a world we have barely begun to read. The moon is not finished speaking. It has been accumulating things to say for longer than the Earth has had a stable surface. The far side, preserved and pristine and electromagnetically quiet, is a library that has never been opened. And the Artemis II mission, in its brief, sweeping passage through the lunar wake, found a page. One page, in a library 4.5 billion years old. The rest of the library is still there, patient, silent, waiting for instruments sensitive enough and minds open enough to read it. The human body was not designed for space. This sentence is so obvious, so frequently repeated in the popular literature of spaceflight, that it has lost almost all of its power to disturb. We say it the way we say that fire is hot or that water is wet, as a fact so fundamental that it no longer registers as remarkable. But strip away the familiarity,